Unit 3, Day 4, Section 1.4 of the textbook. We're talking about mutually and non-mutually exclusive events. So let's do a Venn diagram, and we're going to talk about horizontally symmetrical. So what that means is if I do this, they're symmetrical that way. So if a letter, look at A for example, if I drew a line through A and flopped it over, it would be symmetrical. So what I want to do is let's talk about symmetrical and vowels and both. So G is neither, so we're out here. Okay. A is both, it's a vowel. V is not a vowel, but it's symmetrical, so that's going to go here. E is a vowel but not symmetrical, so that will go there. I is both, so I'm going to jam that in there. N is not either. T is here, and then O is there too, so I should have planned a little bit better. But there's I, A, and O, B, T, E, G, and if we made, so there we have something that's going on here. If we did a Venn diagram and we said, tell me how this looks with vowels and consonants, we don't need to make a Venn diagram like this as vowels and consonants, right? What we do is we could make a Venn diagram that looks like this. We could have vowels and consonants. We know there's no overlap, right? And when that happens, you have what's called a mutually exclusive event. Okay, so that's mutually exclusive. That's what we are, mutually exclusive event. Mutually exclusive experiments often involve using or thinking about the word or pass-fail scenario when it comes to selection. Okay, so it's this or that. So for example, of the options here, what is your favorite ice cream flavor? There's no overlap. There's vanilla and there's strawberry and there's chocolate. So if we were to do this and find out that 5 people said this, 9 people said this, and 1 person said this, and we want to find the probabilities of each occurring, this is an experiment probability, what you would just do for vanilla, so the probability of, let's do strawberry for example, what you would do is say 9 people chose strawberry out of a total of 9, and 1 is 10 plus 5 is 15, 9 over 15, and then figure out that it's 0.6 or whatever that is as a decimal and as a percent. Okay, that's it. When you look at mutually exclusive events, the one thing that you notice is the probability of one happening or the other is the probability of both. So before, when we talk about union and we talk about intersection, when we're talking about, we don't have to deal at all with the union, okay, because there's nothing there. So before we had something like this, A and O, remember we had questions like this and we had to subtract this, the union of A and B. So this was that, right? Sorry, we'd have to subtract the intersection. This was the union, and you'd have to subtract that. But the problem with that, or not the problem, what's going on here is we know this is always 0, so we don't have to do this. You can still write this in here, right? But the intersection size is 1. Okay, so for ice cream experiment, when you talk about this, the probability of, let me go back, remember the numbers here, strawberry was 9, I think, and chocolate was 1, right? So if I go strawberry or chocolate, the probability of that is just the probability of A, which we said was 9 over 15. We didn't do this, but probability of B was 1 over 15. There were 15 options, and it was 1 over 15 that you chose chocolate, and then together they are 10 over 15. Or you could have added them together. You could say 9, how many people chose chocolate or strawberry or chocolate? 9 plus 1 is 10, and a total of 15, same thing. Okay. For non-mutually exclusive events, we need to remember how to deal with that with the overlap. I just said how to do that. Okay, so here you have this and this, and we have to remember that that PA, same thing, PA or B is equal to the probability of A and the probability of B, subtract the intersection. Okay, so we don't want to double count. It's the same thing when we're looking at the size here. So here, if there are 25 students in total, and 9 take math, 8 take art, and 7 take both. Remember when we did this, if we draw it like this, and I'll go math and art, you could have done it the other way around. 7 take both, so that goes here. 18 take art, so 11 goes here, and 9 take math. Remember, how did I get 11? It was 18 total in the circle, 7 go here, so I subtract the 7 to get this. This is 9, that's 2, and then I was told that there were 25 students in total, so there are 2 plus 7 is 9 plus 11 is 20, which means 5 don't take either. Okay, so we talked about union and intersection. This is the intersection, the union. So when we talk about this, remember this is the intersection. The union is the or part, so it's everything in both circles, including the overlap here. And if we were to talk about the probability of this, right? If we were to talk about the probability, and say what's the probability that a student chosen at random takes math or art, you're not going to, you can't double count. You cannot double count the middle, right? So what I'm saying is the probability that a kid takes art would be 18 over 25, right? So let's do this together. The probability that someone takes math or art really means they take math and or art. Okay, so it's the people that take math alone, the people that take art alone, and the people that take both. So in total, we have 2 and 7 is 9 plus 11. That's 20 students. So we know that the answer is going to be 20 over 25. What's the probability that a student chosen at random takes math or art, or both, really, is what we're saying. So what you want to do is you take the probability that the student is taking just art, which is 18 over 25, and you add to that the probability that the student is taking math, which is 9 over 25. Okay, and you're going to subtract this number here, or the probability that they are taking both, which is 7 over 25. And when you do that, you're going to get 18 plus 9 minus 7 is 20 over 25. Now, you don't need to do that if you have a Venn diagram or if you draw a Venn diagram, but if you're given these numbers separately, to get this number here, you'll do that. Okay, so you add the probability of art of one plus the probability of the other, subtract the probability of both. Okay, and that's it. Okay, hope that makes sense. Take care.